Hello everyone and welcome back to the physics radiate tutorial. Today we will learn that how the gravitational field strength varies with the altitude, or we can say with the height. Uh, in previous tutorial we have learned that, for example, if we have the center of mass of the earth and we place an object which has, let's say, mass MO, mass of the object, and we consider that mass of the earth is ME. So from the center of the earth to the body, we have this distance which is uh, the radius of the earth. In this case we will represent it with RE. So we have derived that, for example, in this situation, uh, the G can be written as G, capital G, which is the gravitational constant, mass of the earth, and divided by distance or square of the distance between them. In this situation it is radius of the earth. We have learned that in the previous uh, tutorials. However, now if we place this uh, object above it, so what will happen? For example, if we move this object with some height, let's say over here, so now the distance is different, and we consider that, let's say, the distance, now we cover the distance, that is h. Now the total distance from here to here, that is we consider, for example, r. Now according to the equation, now the distance will be uh, the distance r will be radius of the earth and plus height, which is the altitude of this object from the surface of the earth. So equation 1 can be written as G will be equal to G, capital G, which is a constant value, mass of the earth, which is constant in this situation. Only the distance varies between them, which can be written as RE plus H and whole square. So this equation can tell us that the gravitational strength varies with respect to height. Let's say if we consider, for example, h is 0, which means on the surface of earth the height or the altitude is 0, so we can say that this equation will be the same as before, so which will be G and capital G ME divided by r square plus 0. So we can write it as capital G ME divided by r square. This means that on the surface of earth we have 0 altitude, or the height is 0, so we will get the similar gravitational strength as before. But if we have h, for example, if h is greater than 0, so the G will vary, the G will decrease, as this equation shows us that this is the inverse relation or inverse square law. So if the altitude increase, so the G will decrease, and that is beneficial for the for launching the satellites or artificial satellites around the earth. So that will be discussed in the coming videos. We can write these equation as well in other form. For example, if I write this equation in other form. So how I can write it, as we know that g with altitude, for example, with the height, that is written is g me divided by re square, sorry, not r square, re plus h with respect to altitude, so that is squared. And we can say, let's say this is equation number 1. And also we know that at zero altitude the gravitational field strength is actually the g me divided by re squared. So by cross multiplying this equation, we can say that capital G me can be written as g re square, and we can put this value over here. So 1 can be written as g with altitude, that is gravitational field strength on the surface of the earth, radius of the earth with squared, and re plus h or altitude in whole square. We can define this equation as well. This means that uh, with having different heights from the surface of the earth, we will have different value of the gravitational strength. And in the coming videos we will show that how the satellites can be launched and which velocity is required for the satellites.